Moving on to the next section. This is on solving linear inequalities. So let's first look at the definition of graphing inequalities on the number line. So the question is, what values of x would make this simple inequality true? So what values of x would be x greater than 2 be true? Well, if x was equal to 3, that would work because 3 is greater than 2. If x was equal to 10, then 10 is greater than 2. So that works. If x was equal to 501, 501 is greater than 2. So that works. If x was equal to this decimal, 2.000001, 2.000001 is also greater than 2. So we could literally spend the rest of our lives writing values of x that are greater than 2. But there are better ways to spend your time, and there are better ways to represent values of x that are greater than 2. So you've probably heard the adage, a picture is worth 1,000 words. So now we will create a picture which is worth an infinite number of values using a number line. So what's a number line? So a number line is a horizontal axis with arrows at both ends. So we have a horizontal axis with arrows at both ends, extending into infinity. So this is going to positive infinity, and this is going to negative infinity. Labeled with values, typically integers, above and below the numerical value of interest, 2. So here I've got these tick marks here on the number line. Notice that they are evenly spaced. And I've got one value 0 for this tick mark. And I've got -2 here. And I think to be true to what I just said, the numerical value of interest, I also need to label 2 here. Okay, so each tick mark is 1. So we've got 0, 1, 2, 3, 4, 5, 6. Then on the other side is 0, we have -1 and -2. All right, so one needs a way to label greater than, less than, not equal to, versus greater than or equal to, or less than or equal to. So we're going to use open circles, closed circles, parentheses, and brackets to represent these inequality symbols. So for any inequality that's actually an equality, we're going to use either a closed circle or we're going to use brackets. Okay, so closed circle or brackets. If we're using an inequality without equals in it, then we're going to use an open circle or parentheses. Right? We will be using parentheses and brackets when we do interval notation. But it's not uncommon in mathematics also to see open circles and closed circles, or open dots and closed dots, to also represent these inequalities as well. So that's why I'm giving you both. Okay, so what does x greater than 2 look like on a number line? So one can represent every value into infinity by drawing an arrow into either positive infinity or negative infinity. All right, so the answer is using open and closed circles. So because we've got x greater than 2, this greater than means that we're going to use an open circle or parentheses. So here we're going to represent x greater than 2 using an open circle. So we're going to put an open circle at 2. So here's 2. So we're going to put an open circle here. And we want values of x that are greater than 2. So that's going to be values to the right. So I'm really going to kind of lean into this. We're going to darken that out. And I'm going to make this an arrow showing that it's going into positive infinity to the right. So starting at 2, but not including 2, that's why we're using an open circle, and then drawing an arrow to the right. That is representing visually or graphically this inequality, x greater than 2. So values of x are out here. Now, if we're going to use parentheses, we're using parentheses because it's a not equal to inequality. Again, we're going to start at 2. Oh, I started to draw a circle, didn't I? So we're going to draw parentheses at 2, and then we're going to draw our arrow. And this is where our values of x are going to live. Now, notice the direction of the parentheses. I didn't draw the parentheses like this and go in that direction. Okay. Trying to think of maybe some kind of device to help you remember. I guess I would just maybe almost think of, this is maybe, you're cupping your hand. You're cupping your hand. So, here's your thumb. And then here's your thumb, and there's your arm. This is a terrible drawing. And so here's your fingers, here's your wrist, here's your thumb, like this, and you're holding the values of x in your hand. So you're kind of cupping your hand in the direction of the x values. So maybe try and think of it that way. With this open dot, just think of it being hollow. So it's hollow. It doesn't include the center. And so this does not include 2. All right, so using open and closed circles or parentheses or brackets are equally valid, though using parentheses or brackets will translate better with interval notation. So let's talk about interval notation. So we just gave an example of graphing this inequality x greater than 2. So here's 2 on the number line. This is going to kind of give me some little fits here. Okay, that's better. And so to represent this with parentheses, let me use a different color. So I used a left parentheses, and then I drew an arrow to the right into infinity. So this is very much how we're going to write this in interval notation. So notice that we have a left parentheses here, and the left parentheses was placed at 2. And this goes from 2 to positive infinity with a right parentheses there to close that off. Right, so this is interval notation. So this mathematical notation is equivalent to this graphical picture. So when you're communicating to someone or you're writing an answer and you write it in interval notation, this is the picture that's being formed in that person's head. So these are equivalent forms, just one's graphical and one's mathematically literal, I would say. All right, so let's look at another example here. So let's look at the one down below. Okay, because this is still dealing with a similar type of inequality. So rather than x greater than 2, now we've got x less than 2. All right, so now that we're talking about values of x less than 2, now we're going to be going into negative infinity now. I apologize for my text kind of moving around on here. It's something that Word does. I haven't figured out how to correct it yet. Okay, so here at 2, We know that the values are going to go from 2 and to the left, right? Because these are values of x that are less than 2. So we need to make a right parentheses now, kind of like holding or cupping the values that are going in the negative direction. Okay, now if we look at the interval notation we put above, okay, it's written from left to right. And what I mean is from left to right in the graphical picture, we had left parentheses, 2, and then going to infinity with like a right parentheses here. Okay. So the same thing is going to happen when we write interval notation for this one. We're going to be starting on the left, and we've got like a left parentheses, negative infinity, and then to the right, reading left to right, we're going to have 2 and right parentheses, 2 and right parentheses. Okay, so you draw or you write interval notation from left to right as though you were looking at a number line from left to right. Okay, so let's look, at a new example. So we can have inequalities without equals in it. But now let's look at some inequalities that have equals in it. So here we've got x is greater than or equal to 2. So here's 2. It keeps shifting it in the way. So here's 2. And now, because we've got x is greater than or equal to 2, now we're going to use brackets. And now we're going to use brackets. And since we're looking at values greater than 2, okay, then that's going to be an arrow going to positive infinity. That. And now we're going to use a left bracket kind of opened to the values that are going to be greater than 2. And so this bracket means that we are including 2 as part of that set of numbers. And when we use brackets like this is how we make it in interval notation. So left bracket 2, and it's going to infinity, parentheses. And when we look down here at x less than or equal to 2, okay, here's 2 on the number line. We want values of x that are less than 2. We're going to have this arrow. And then not only do we want values less than 2, but we want values that also equal to. So now we're going to put in a right bracket. And this is where our values of x are going to live. And so as we read this number line from left to right, we've got parentheses, negative infinity, and then comma, 2 right bracket. All right, and so you'll notice that, we change using parentheses and brackets based on the inequality that we've got. So here, since we had greater than or less than, we used parentheses on the 2. Okay, we used parentheses on the 2. But when we had greater than or equal to and less than or equal to, then we used a bracket next to the 2. But also notice something that did not change. Something that did not change was that regardless of the interval, we always had parentheses next to the infinity sign. We always had parentheses next to the infinity sign. Always had parentheses next to the infinity sign. Always had parentheses next to the infinity sign. So that's something to always remember. When you're doing interval notation, next to the infinity sign, you'll always draw a parentheses. That'll never change. The only thing that'll change on interval notation is the actual boundary line. some value. Could be an integer, it could be a fraction, it could be just a real number in general. That's when you have to pay attention as to whether it's going to be parentheses or brackets. And that's kind of just what I just noted down here. Okay. And what you'll also see too is you'll notice sometimes I put positive infinity and sometimes I just put infinity. Don't be surprised if you often see just infinity without the plus sign. It's just kind of assumed that's positive infinity. Okay, so let's look at a quick example. This is example 251. So graph each inequality on a number line and translate the inequality into interval notation. So now this is a fraction. So let's go ahead and create our number line. And we're going to have 0. And let's see here. So we're going to graph this from 0 to 1 and 0 to -1. But we need to do it in fifths, which means that we need to have 4 marks between 0 and 1. So we're going to have 1, 2, 3, 4. There's our 5th one, so that's +1. Then we're going to have 1, 2, 3, 4, and then the 5th one will be -1. Make this a little bit darker. Okay, so then we're going to have -1/5, -2/5, -3/5, -4/5. It's messy. And of course, -5/5 is just -1. Okay. Okay, so we know that we're going to land. We're going to land on -3/5. Okay, so we're going to be on this number. Let's do this one with either open circles or closed dots. Okay, so this one we're going to use either an open, closed dot. So which are we going to use? Well, our inequality is less than or equal to. So the rule is if it's less than or equal to, if it's equal to, then we're going to use a closed dot. So here at -3/5, we're going to use a closed dot. And we're interested in values of x that are less than -3/5. So that's going to be towards -infinity, like that. So this is where the values of x are going to live. Values of x that are less than and equal to -3/5. Right? And just for kind of completeness, let's go ahead and do this with parentheses and brackets as well. And I'm just going to mark -3/5 here. Put arrows on either ends of the number line to show it goes into infinity. Okay, so now to denote using parentheses or brackets, we're going to use a bracket. And the bracket means that it includes that value. And this is going to be a right bracket because we want values, we want it to be open to values of x that are less than -3/5. Okay, so now we need to translate it into interval notation. So x is going to be equal to, now we need to put this in interval notation. So reading from left to right, we've got -infinity, it's going to -3/5. And next to the infinity sign, we always have parentheses. And to show that we want to include -3/5, we need to put a bracket on this end. That's our answer. So this is how you take this most basic inequality, and you can graph it on a number line with either a dot or parentheses or bracket, and then how you interpret the picture of that number line as interval notation. So with that example as a model, use it to graphically represent both of these inequalities in this think pair share 251 A and B, and also come up with interval notation for the solutions for both of those. Give that a try.